Okay, so we are going to start on our last video for this year. Hopefully you have enjoyed lessons by video because next year we'll be doing them pretty much all the time. So today we're going to have the angel watching over us as we talk about similar solids. Okay, so similar solids is all about ratios and proportions. So you've got to think back to more towards the beginning of the year when we talked about ratios and proportions, understanding that we're going to use some cross multiplication to solve for some things. It's really a very easy, and it's an easy thing that we're going to be doing. So first we're going to try to determine if our two, whether our pair of solids would be similar. So we're going to be looking at, and luckily we've got rectangular prisms, so you'll be able to actually see what I'm talking about. And we'll have one that is slightly larger. Okay, oops, we're going to be going into my similar solids there. So we've got two solids, different sizes. We've got 10 kilometers, we've got 18 kilometers, we've got 15 kilometers, and we've got 26 kilometers. And all we have to do is set up a proportion, well actually set up two ratios to see if it does form a proportion. So I'm going to put my 10 over 18, okay, this side over this side, so I've got to do the same, 15 over 26. I am going to look at this and say, okay, well, I know that I can reduce this to 5 over 9, but if I multiply this 5 times 3, I get 15, but if I multiply 3 times this 9, I get 27, okay, so I get 27, so this is not a proportion, okay. I did that a little fast. I hope that you kind of could follow. All I did was reduce this ratio to see whether or not this reduced ratio could become this, and it can't. So this is not a proportion, so these are not similar solids. Now our second one that we have is a cone. Okay, so we've got a smaller cone and then we've got a bigger cone, and they are both made equally as bad, and you can't see them at all. There we go. And we've got 11.2 yards on my slant and 7.2 on my radius. And on my larger one I've got a 9. And I've got 14. So I'm going to go ahead and set this up. I'm going to say 11.2 over 7.2 is equal to 14 over 9. Okay, I am actually going to have to cross multiply this. Oop, notice I put this. That shouldn't be there yet. 14 times 7.2, and that's 8, 2, 8, 7, 8, 9, so 8, 1008. So 14 times 7.2 is 1008, and now 11.2 times 9, and I had a decimal point there, sorry. Okay, and that's 18, 9, 10, 9, 10, another decimal point, 100.8, and yes, it does equal, so it was okay that I wrote the equal sign, but you should never do that beforehand. Now, I set up my ratios this way, as long as you make sure that you set them up the same. I could have done 11.2 over 14 equal to 7.2 over 9. I could have set them up that way. I could have flipped it where it's 14 over this and 9 over this. So as long as you are comparing the same things, you can set those ratios up whatever works best for you. So that's how we find out that they're similar. Now, what if we're missing a length? Well, we go back to those ratios and back to our understanding of proportions. So let's say we've got triangular prisms. Okay, so this is going to be really bad. So it's just, you know, you're going to have to just try to, it's not as horrible as I thought it might be. Okay, this one, it's here, and here, and oops, and it comes here, and here. Okay, so this is A and this is B. So I've got, this is H here, and I've got 24 feet here. 24 feet. And I've got 8 feet. Obviously, these are not drawn to scale. And I've got 10 feet here. 10 feet. Okay? So all I have to do, because they are telling me that they are similar, so I'm going to say, okay, I'm going to do H over 24, and that's going to equal, here's my 10 over 8. Now, there's a couple of ways to do this. I know that to get from 8 to 24, I have to multiply times 3, so that means I have to multiply 10 times 3, so that makes H equal to 30. Okay, so that means that this H is equal to 30 feet. That was pretty simple. I could have done this measure over this measure. That's also another way to do it. 24 over 8 equals, okay, and then it would be H over 10. H over 10. This would have reduced to 3 over 1, and 1 times 10 is 10, and 3 times 10 is 30. So I could have done it that way. No matter which way I do it, it's still going to come out to H equals the 30, and hopefully that was pretty easy and understandable. So now let's get to the part that is a little bit different, where they tell us what our scale factor is. So I don't know if you remember when we talked about maps and blueprints and we had scale factors. Well, with this we also have scale factors. So let's say we are working with, let's see, we've got a scale factor between a baseball and a softball of 1 inch. So our scale factor, factor, boy, it's getting late. Our scale factor is 1 inch to 1.3 inches. Okay, and this is our baseball to a softball. So I'm just going to write baseball, softball. And the volume of a baseball is about 12.8 inches cubed. So volume of a baseball is 12.8 inches cubed, and they are looking for the volume of the softball. So when I have scale factor and I'm working with that, I just use my ratio when I'm working with volumes. I use my ratio, let's call this A and this B. So we would have A to B, and I'm working with volumes, so I'm cubing it. That's all we're doing here, okay, is that we're working with this and we are cubing it. So I'm just going to go ahead and literally, if I look at cubing this, then my volume comes to 1 inch, because 1 cubed is 1, because 1 times 1 times 1 is 1. But now I have to cube my 1.3. So we're going to go ahead and say 1.3, and let me just bring this down a little bit, times 1.3, 9, that's 3, and that's 3 and 1, 961, 1.69, and 1.69 times 1.3, 7, 2, 18, 20, 3, 4, 5, and 1 times 9, and 6, and 1, so that's 7, 9, 11, 2, and I have 3 decimal places, so this is 1 inch cubed to 2.197 inches cubed, and so I'm going to cross multiply. So, and this is x here because we don't know that. So I've got x equal to 12.8 times this. So I'm going to take my 12.8 down here, 8 times 7, and let me move this down a bit more. 8 times 7, 56, 8 times 9, 72, 77, 8 and 7 is 15, and that's 16, 17, 2 times 7 is 14, 18, 19, 2, 3, and 4, and then 7, 9, 1, 2, 6. It's a lot of multiplying. 6, 15, 22, 2, and that's 9, 18, 21, 2, 3, 7, 8, and 2. And I've got 4 decimal places, so it comes here. So x is going to be 28, and we'll go to the 10th.1 inches cubed. So that is what the volume of the softball will be. Okay, so all you're using is that ratio and you're cubing it. You can use that ratio for a lot of things. So you'll see when we do some problems tomorrow how easy it is to use it. It's just a scale factor and you're just using it and multiplying it. So hopefully we won't have any problems, but if we do, we always have the angel watching over us. Okay, so thank you for watching.